To build a database using the top-down design, we start with the Cube Wizard. One of the steps in the Cube Wizard is to select a creation method. And here's where we select Generate Tables in the data source, or we could create an empty cube to start the top-down design process. There's also a drop-down here to select a template, which just serves as a starting point that we can use for our design, and we can always make changes to that design later. To continue to the next page of the wizard, if we do not select a template, then we just define the measures we want to use. Measures are the numeric values that are the basis of our analysis, such as sales, or number of units sold, or the cost of the item sold. We can combine multiple measures into measure groups. The rule here is that for all the measures in the same measure group, we'll need to provide consistent granularity. That means the data for each measure is at the same level. We're not mixing daily data with monthly data, for example. In this case, we have sales amount, order quantity, and product cost all in the same measure group, so we need to associate all of them with the same dimensions and the same level within each dimension. For example, all three of these would be associated with a product, a date, and a sales territory. Thus, each row of data in our source table that will get generated when we're done with the design process will contain a reference to product, date, and sales territory. That's the granularity, plus the three measures. Notice that we also specify a data type and an aggregation function. Most often we use sum as an aggregation function, but we can also use min, max, count, and distinct count, as well as some others for special use cases. On the next page of the wizard, we deal with dimensions. We use dimensions as a way to group our measures for analysis. For example, we might analyze sales by date and by product. Let's look at a simple example here. First, we can select dimensions from a template, time for example, which could be called date. The time dimension is something that has common components across databases, so a template is a good place to start. But we can also add other dimensions that don't come from a template. Here I've got 4: product, subcategory, category, and sales territory. Actually, product, subcategory, and category are different levels in the same dimension, what we would call a snowflake architecture, which we'll discuss in more detail in the dimension development module. A snowflake has one table per level of a dimension, but the only way for us to produce 3 separate tables using the top-down approach is to set them up as individual dimensions here, and then we can make the changes to the database later. A snowflake has one table per level of a dimension, but the only way for us to produce 3 separate tables using the top-down approach is to set them up as individual dimensions here, and then we can make the changes to the database later. Another decision to make here is whether to support slowly changing dimensions. We just select a checkbox here, and columns to handle slowly changing dimensions are added to the table design. In a nutshell, slowly changing dimensions allow us to do versioning for records stored in a dimension table. So if a product gets assigned to a different subcategory, we would have one record for the initial subcategory and a separate record for the new subcategory. Not shown here will be a page in the wizard to associate each dimension with a measure group, which is the same thing as setting dimension usage, which we'll learn more about in the cube development module.